Welcome back, everyone. Well, let me ask you this question. Did you ever wonder, where did the universe come from? What was there before it? What will the future bring? And finally, the big question we're going to try to tackle today is, why is there something rather than nothing? Well, one of the few prominent scientists today to have crossed the chasm between science and popular culture is Dr. Krauss, who describes the staggeringly beautiful experimental observations and mind-bending new theories that demonstrate not only can something arise from nothing, something will always arise from nothing. That's right, Dr. Lawrence Krauss seems to have the answer. We're going to find out today. But who is Dr. Lawrence Krauss? Well, if you haven't heard of him, he's the director of its Origins Project and foundation professor of the School of Earth and Space Exploration at Arizona State University. Without further ado, let's welcome Dr. Krauss to the show. Welcome, Dr. Krauss.
It's nice to be there virtually.
Virtually, that's right. So this is a fabulous book. The first question I always ask all my guests, especially authors, primarily is, what motivated you to write this book?
Well, I think what really motivated me was that there's been a revolution in our understanding of the universe that's been incredibly exciting over the last 50 years, and I wanted to communicate that excitement as well as the potentially profound implications that have come from those developments. That, and I guess I get hit a lot by people who view the Big Bang as kind of the last bastion of God, and that even those who accept evolution, which of course they should since it's a fact, might figure, well, the one place you really need God is to create a whole universe and all the 100 billion galaxies, each containing 100 billion stars, and so I thought it was the fact that the new developments have really challenged some conventional beliefs and caused us to rethink of what the universe can be, how it could have begun, would be exciting to talk about, and also demonstrate that in principle you don't need any supernatural shenanigans to make a universe.
I like that. Let me ask you this. In regards to your book, it seems like quantum mechanics is giving a lot of the answers to why is there something rather than nothing. Is that true?
Well, quantum mechanics is a key part of modern physical theory, and it demonstrates that when you take quantum mechanics and put relativity and quantum mechanics together, you get some very strange things happening at a fundamental scale. You get the fact that empty space is not so empty. It's a boiling, bubbling brew of virtual particles popping in and out of existence all the time. And that means that the universe is stranger than you might have thought. And then when you apply quantum mechanics to maybe gravity, things get even stranger, because you can imagine whole universes popping into existence and out of existence. And of course, with that comes the possibility of creating a universe quantum mechanically, spontaneously, where there was no universe before.
So let's delve into the book a little bit. I know we have a brief time with you today, and we really appreciate the time. Give us a little brief summary of the book. What's some of the points that you want to get across to our listeners?
Well, what I really want, the main points are that one of the things is that we have learned remarkably over the last 50 years that the universe is not what it seems, that most of the energy in the universe doesn't reside in the stars and galaxies we see, and we're able to look back to early moments of the Big Bang, and we look around and we discovered that roughly, to our amazement, 70% of the energy of the universe resides in nothing. And by nothing, I mean empty space. And by empty space, I mean you get rid of all the particles and radiation and everything that's there, and that space still weighs something. And we don't have the slightest understanding of why. And that's probably the biggest mystery in science. And trying to understand that will undoubtedly give us new insights into the beginning of the universe and potentially the end. But also, the rest of, so 30% of the universe is matter. But most of that matter isn't the same matter that makes up stars and galaxies. It's something we call dark matter. 90% of the mass of our galaxy and all the galaxies around us is made of stuff that doesn't shine, and we're pretty convinced that's a new type of elementary particle. So everything we see, all the stars and galaxies and everything we see, account for a 1% bit of pollution in a sea of dark matter and dark energy, as we call it. And you could get rid of us and everything we see, and the universe would be largely the same. So much for a universe made for us, I guess. And that path of discovery is remarkable, and I wanted to communicate that. But then I wanted to talk about the implications, because we've realized not just that, but we've measured the geometry of the universe, something we've been trying to do since Einstein first told us that space could be curved. And we've discovered that the universe is flat in 3 dimensions, which means there's just enough matter and energy to balance gravitationally, so you get, on the whole, light travels in straight lines in our universe. Well, that may or may not be interesting, but in a flat universe, the gravitational energy of every object is precisely zero. And that begins to suggest that we start thinking about whether to create a universe from nothing, because matter, of course, has positive energy, but when you allow gravity, you can have negative energy, and the two can balance out. And you can come up with a whole universe, including, indeed, our universe, with 100 billion galaxies, each containing 100 billion stars, where the total energy of the universe is precisely zero. And if that's the case, you can create a universe from nothing without violating any laws of physics. And that possibility, even though we don't yet know exactly how to do it, but the plausibility of that possibility is certainly worth celebrating, because it means that, in principle, we have a mechanism to create a universe just using known laws of physics, just like Darwin gave us a mechanism to understand the diversity of life on Earth without any divine intervention.
That is profound. So it sounds like you're also saying that religion does not require a God. I mean, science does not require a God, sorry.
Well, science has never really required a God. God has been irrelevant to science for the most part. We've never demonstrated the need for anything supernatural in the laboratory or anywhere else, or any evidence of purpose. So God has been just irrelevant when it comes to understanding the physical universe. People seem to think there's this intimate relationship between science and religion, and there really isn't, because I've been a scientist for 35 years, I've never heard the word God mentioned at a physics meeting. So certainly, we don't need God to create the weather, we don't need God to move the planets around. All the things we thought in the old days that we needed gods for, we discovered one by one that the laws of physics and chemistry and biology can help us understand the universe without any need for God or angels or anything else. And that was true. That's been true as long as we've continued to do science. But what's amazing is, even when we look at the fundamental fabric of the universe, when we look at the landscape and the tapestry on which the universe is made, on the largest scales back to the earliest times, the times when you might have thought you needed to invoke God, we've discovered that even there we don't have to.
Let me ask you this question. We've had some really new discoveries in the recent year or so, if I'm correct, and you're the expert here, so you have to forgive me for my naivete. But any of those new discoveries in regards to the Higgs boson or dark matter, have they corroborated more this theory?
Well, I mean, they're all part of the same picture. It all works together. The dark matter, of course, has been a central part of beginning to understand the universe on larger scales. The Higgs particle is a great discovery that reveals to us a standard model of elementary particle physics works, but it also begs interesting questions about how the standard model might be supplemented that are relevant for dark matter. It all comes together. It's not as if there's one theory here and one theory there. All these ideas point to the possibility that our universe isn't unique. That's another thing I talk about in the new book, that there may be many universes, perhaps an infinite number, and that that the laws of physics might even be different in each one. And so everything, sort of, all of our ideas are being applied as we try and understand nature at its fundamental scales and also at its largest scales.
That really complicates matters, adding multiple universes.
Well, I mean, maybe it makes it complicated. Maybe it makes it more interesting. We'll
sure.
see. What's amazing is we can turn metaphysics into physics. That it's possible that we'll not be able to get direct evidence of other universes, but certain things we might see, like gravitational waves from the beginning of time, may give us strong indirect evidence of the existence of other universes, and that's kind of amazing.
That is amazing. I have to ask you a couple of questions that just popped in my head. Let's see how you tackle these. One of the questions, in this theory, does it give any room, or doesn't it even matter in regards to extraterrestrials?
Well, of course there's room for, when there's 100 billion galaxies, each containing 100 billion stars, there's lots of room for life on other worlds. It's hard to imagine that there isn't life somewhere else in the universe. Certainly, maybe even microbial life in our solar system. Whether there's intelligent life elsewhere, of course, is an open question. But it's hard to imagine that there isn't somewhere. The universe is a big place with lots of stars and we've discovered almost all stars have planets around them, and so absolutely. The point is that there's no evidence that they've been visiting us. In fact, there's no. If you think about it, the likelihood is essentially so remote as to be essentially impossible. And so, unfortunately, while there may be intelligent life in the universe, the likelihood of actually ever knowing about it directly is going to be pretty small.
Yeah, Area 51 fans aren't going to be too happy about that, but that's all right. Dr. Krauss, let me ask you this question. Go ahead.
The way it is, whether we like it or not, and that's something people should realize. Whatever we want and like, the universe is the way it is.
Let me ask you this question. That does provide some people with a problem. You know, what I'm talking about here are some people who believe in creationism, that God created the world, or intelligent design. What does it say to them? What do you think? In regards to your book, what does it say to them? Because now they've lost the ability of, I guess they kind of lost the ability of intelligent design. They can still believe it if they want.
Well, I mean, intelligent design is an idea that has never been successful. People have tried to apply it to understanding life on Earth, and of course, it's not science. It's wishful thinking. Every time people have come up with proposals for how there might be evidence for intelligent design, they've gone away. It's not a scientific endeavor. It's just not worth talking about. So, I mean, maybe people might like the idea, but once again, the universe is the way it is, whether we like it or not. And there's no science being done. Evolution, natural selection and evolution describe perfectly all the predictions of it, describe perfectly everything we see about the nature of life on Earth. And of course, there's new things to be learned, but invoking some weird intelligent design doesn't help. In fact, if you have back pains or your legs hurt at night, if you wanted to intelligently design human beings, you could do it a lot better. You could make sure that they didn't breathe through the same hole they ate in, and all sorts of, and you wouldn't put blind spots in the back of their eyes, and all sorts of things. So the notion of intelligent design may appeal to people, but it's really not viable, certainly when it comes to life on Earth, and there's no evidence for intelligence in the universe either. That doesn't mean there wasn't some purpose, but it's certainly no evidence for it.
That's a good point. We have about 2 minutes left. I know you got to run. We appreciate your time. What's the main takeaway you want people to have from this book?
Well, that the universe is an amazing place, that it's remarkable, and every time we open a new window on nature, we're surprised. And the universe is so amazing that you don't need to add all the garbage. You don't have to add all the superstition and myth and supernatural. The universe is plenty amazing as it is, and every day we learn more about it. And in fact, we should force our beliefs to conform to the evidence of the universe and not vice versa. We should enjoy the remarkable nature of the universe and not mind if we're insignificant. The meaning we make, the meaning of our lives is the meaning we make, and our lives are more precious if we determine our own meaning than if it's determined by some cosmic Saddam Hussein in the sky.
Let me ask you this. Last question. Can we get a sneak peek here on what your upcoming book is? I heard that leak out a minute ago.
Well, I have a new book, but it won't be out this year. It will be out early next year. It's taking, I guess, because the presidential election, they've decided to delay it. But it's called The Greatest Story Ever Told So Far. And it takes off where the universe from nothing left off, or the universe from nothing addressed the question, why is there something rather than nothing, and looked at the large-scale universe. Now I'm looking at the fundamental structure of matter in the universe and addressing the question not why is there something rather than nothing, but why are we here?
Interesting.
It follows what I think is the greatest intellectual journey humans have ever taken.
It might be a good idea to release it after the election, because I think Donald Trump might have thought you were writing about him. Dr. Krauss, where can we get more information about you?
Well, you can go to my own personal webpage at the Arizona State University, which also lists the places I'm talking and when and where, and it's krauss.faculty.asu.edu. But you know what? You can Google me, and I'm all over the place. So you can watch me on YouTube. You can and look at the Origins Project. Go to the origins.asu.edu and see all the events we run, many of which are videotaped and archived, and they're amazing. We've had panels on the beginning of the universe, dialogues with Noam Chomsky and Johnny Depp most recently, and it's a fascinating I'm privileged and thrilled to be running the Origins Project here. And we run events where 3,000 people come, members of the public come to listen to science. So I don't think that happens anywhere else in the country.
Absolutely, everybody. Dr. Lawrence Krauss, the book we were discussing, Why There Is Something Rather Than Nothing, A Universe from Nothing. Look up Dr. Lawrence Krauss. He really is all over the internet. You can find him on YouTube. Anywhere you Google him, you'll find him. Thank you again, Dr. Krauss. We truly appreciate it.
Well, thanks again. It's been a pleasure.